Hi, thank you for joining us for this video where we will use Protobuf with AWS IoT using open source, where we will look at an automotive scenario. My name is Syed Rehan, and I'm Senior IoT Developer Advocate within AWS IoT Service Team. So in this video, we will look at what is Protobuf, how we can utilize Protobuf using AWS IoT rules. We will do a walkthrough and how we can utilize that fan out to Amazon S3 from AWS IoT Core. So what is Protobuf? Protobuf, which is a short form of protocol buffers, is an open source data format. It is used to serialize structured data in a compact binary form, and it is used for transmitting data over networks or storing it in files. So Protobuf allows you to send data in small packet sizes and at a faster rate than any other messaging format. So how does AWS IoT support Protobuf? So AWS IoT Core rules, which is one of the features of AWS IoT Core, has called Rule Engine, which supports Protobuf by providing a decode function. We will look at that decode function later on, how we can use that. So decode function actually provides a value parameter and it also provides a decode schema parameter. And it is actually a SQL-like function, which allows you to decode protobuf encoded message payload to JSON format and route them to downstream services, i.e. in this case, we will look at Amazon S3. So let's go through and do a walkthrough. Before we switch over to AWS console, hint to all our viewers, all the code, the command we have used in this video will be available on GitHub in the description of this video. Okay, so I have actually set up a Cloud9 environment, which I am using it to replicate a device in the field, which is an edge device in this case. And I will basically sending the data from here to AWS IoT Core and further downstream into a Amazon S3. So before we can start, we need to make sure we have a Protobuf compiler, which is an open source compiler, and it can be obtained of github.com/protocol buffers protobuf releases, and you can download it from there. Okay, so the first step is to actually create a protobuf message type. So in this instance, what I would do, I would actually create a protobuf message type. So I would call it automotive.proto. So I have created this message earlier. So let's walk through. Here I'm using protobuf 3. I'm defining a package type, automotive, and giving a message, automotive, with multiple parameters. We have battery level, battery health, battery discharge rate, wheel RPM, and mileage rate. These are usually most common scenarios used by automotive manufacturers to report data from the vehicle to the user and to the cloud. So once we have created our protobuf file, naming it, so in this case, I'm naming it as automotive.proto. What we will need to do is we will need to create a descriptor set. So description set actually contains a message definition using the tool which we have called Protalk, which is a protobuf compiler, and it will generate a file descriptor set file with an extension .desc descriptor set. So let's create a descriptor. So here we can see I'm calling a Protalk compiler. I'm providing the descriptor set out. So in this case, I'm giving the file name what it should be, automotive descriptor set.desc, protopath, where the path where I have all these things stored, including any imports. So in this case, I'm trying to import automotive.proto, which is our protobuf file. Let's go ahead and create a descriptor. So we can see the descriptor has just been created. Okay. We will need to create an S3 bucket and allow permission for the rule to access this S3 bucket to write the output or decoded JSON output into this S3 bucket. So I have actually had created an S3 bucket earlier. So I will just go to Amazon S3. So I've had created a protobuf bucket earlier, and I have uploaded our descriptor set out descriptor file, which we have just created. What we also need to do, we need to basically set up permissions to make sure AWS IoT rule can access this, which I mentioned earlier. So what we will need to do, go into permissions and go into bucket policy and give a set of statement. So in this case, I'm giving a statement, and you can add multiple statements. So more specifically, I have got statement two, which has allow for service iot.amazonaws.com for get, and for the file descriptor, which is a bucket name here, and then the descriptor name itself. Once that's done, you can update that and come back and move on to the next step. So the next step is to actually create a topic rule. For that, we will switch it over to AWS IoT Core, and we will basically create a rule. So under message routing, we will look at rules, and I had created this protobuf test rule earlier. So let's just look at that. So let's look at this SQL statement. This is the one I've created earlier for protobuf test, which I've created the AWS IoT rule. In this case, what we can see here is a select statement which has a decode function. This decode function is something which we have just released in reInvent 2022, which allows us to have multiple parameters. So let's walk through what is actually happening here. In this case, what we can see here, we have decode, and within that we have encoded based 64 for the binary payload. I'm also defining it as proto, which is protobuf, and then I'm also giving my protobuf dash file descriptor, which is actually is Amazon S3 bucket name, which I've created. I'm also giving a file name for the descriptor, which we have created earlier. And then we have, if you remember earlier, we have automotive and auto, which was the package name within the protobuf file, and the message of automotive, which is again from the protobuf file. And then I'm also giving into a topic, which is where I will publish this message to, which is in this case topic forward slash protobuf. Now, once that's done, we need to basically make sure that this rule gets executed. And what I have done is basically I have created action here in this case, an S3 bucket. So as part of an action, if you go here, I basically define my bucket name to say that create an output.json as part of the execution of this, run this function, put into a bucket with the name out.json. Okay, and I've also put in republish to AWS IoT in instances where we don't want to leave the AWS IoT core dashboard. We just want to see actually it has happened or not when we are actually monitoring topic forward slash protobuf. We can easily watch this and republish to the AWS IoT topic. So in this case, what I have done is that when this rule executed, we are republishing the data to a topic called test forward slash test. Okay, now that the rule is created, now let's look at creating a message payload. So let's switch it over to Cloud9 instance, which is representing our end device. And let's create a payload. So this payload I'm actually creating to show you how the process works and how you can basically encode and decode it. In a real world scenario, you would have a program written either in C++, Java, Python, Go, or whatnot, which will automatically creating this payload for you, and it will get decoded and encoded as basically the whole process runs through automatically. So let me just go ahead and create payload. So if we look at the protobuf file comparison with this payload, we can clearly see it is mapping correctly. It is battery level, battery health, battery discharge rate, wheel RPM, and mileage left. So let's go ahead and save this. Now, once the file is saved, we need to create a binary payload. This is the payload which we will actually use to send it to AWS IoT Core. So let's copy the command. So let me just run through the command, what actually happened. I'm taking this payload which we have just created. I'm running a protobuf compiler, which is an open source compiler, encoding the package automotive and the message automotive from the protobuf file. And then we also have descriptor set in this case, the descriptor file, and outputting into binary payload. So if you go ahead and see, binary payload was created without any issues. Now we can see the payload is created. Now let's go ahead and publish this payload to the cloud. So let me just paste this message and walk you through. So I'm running AWS region, which is in this case Frankfurt, which I'm sending the message to endpoint URL, which is my endpoint, and I'm publishing the data to the topic, topic forward slash protobuf, if you remember earlier, which I was basically given it to my AWS IoT rules, and the file which I'm using in this case, which we have just created, binary payload auto. So before I hit enter on that one, let's go ahead and subscribe. So in this case, I will put in hash. It will subscribe to all the topics where the data will be listened to. So if I just go ahead and hit enter, we should see message coming in. So voila, there we go. So we can see here, this is executed. If you remember, I created a republish, which was an action to say that once it's decoded, send the data out to to republish to topic test forward slash test. So in this case, it has given a decoded value of JSON payload. And if you can see also here, this is the protobuf. This is a binary payload before it's basically got decoded. Now, if we switch it over to our S3 bucket, we should be able to see a JSON file created. I'll come in here and let's look at out.json and download it. So let's look at this downloaded JSON output file. We can clearly see battery level, battery health, battery discharge, wheel RPM, and mileage left. So there we go. This shows us how the AWS IoT rule has decoded the protobuf binary payload. So let me just walk through what has actually happened here. We had created a protobuf file with the label .proto, which contained the protobuf context to say that what type of message is going to go, what type of parameters we're expecting, and what data types would it be in this instance, integer or string and whatnot. After that, what we did, we created a file descriptor set, which will be basically created using Protalk, and it allowed us to basically give it to Amazon S3 to basically decode this function based on this descriptor. And then we basically uploaded this file descriptor to Amazon S3, and uh, we made sure that it is basically available by setting up the permissions section over here, where we define the Amazon files, Amazon S3 bucket name, as well as the descriptor. After that, we created AWS IoT Core rules, where we added two actions. So we did two actions within AWS IoT rules. First action was S3 bucket, store the decoded message into Amazon S3, which was out.json, and then also republish the decoded message to a topic test forward slash test, which we saw that in action earlier. And once that was done, we created a message payload, which was a clear text payload. So which was done in payload.text. So if I do payload.text, it was just like a normal scenario, a device creating battery level, or a car creating a battery level, its health of the battery, how quickly it's discharging, the wheel RPM at the time, mileage left on the battery charge, and so on. You can have multiple parameters. You can increase the parameter as you go along. That shouldn't be a problem at all. Once that's done, we basically took that and we actually created a binary payload. So in this instance, so if a scenario is that if an electric vehicle or a car or automotive vehicle basically is creating all these parameters, the device or the car manufacturer can basically use this parameter, serialize it, and into a binary payload and send it across to AWS IoT Core. And this is where we can decode it and convert it into a JSON format and push it to Amazon S3 or downstream anywhere else where the manufacturers would like it sent to. It can go into analytics section, it go into Kinesis, it can be go into any section or action it can do if depending on manufacturer's action. So in nutshell, we have looked at the latest feature of decode function utilizing Protobuf compiler, which is an open source compiler called Protalk. So with that concludes our walkthrough. And thank you very much for watching. If you have any questions, as I mentioned earlier, please feel free to reach out to me either on LinkedIn or Twitter. I'm always happy to help. So have a great day. Thank you for watching. Bye bye.